Hello everybody and welcome to Storage in Microsoft Azure Stack. My name is Heiko Ulrichs. I'm a senior consultant with Microsoft Services and I'll give you a quick introduction into storage in Azure Stack today. So let's start. First of all, the agenda. We'll get an introduction into Azure Stack storage by having a quick overview about the storage services in Azure Stack. We'll talk a bit more about storage types like disks, blobs, tables, queues, storage usage, as well as storage management. Let's start with Azure Stack storage. This slide might look familiar to you. It's more or less the same in Azure with some minor differences. On the left side, you can see all the infrastructure as a service components like storage, virtual machines, networking. In this area, we mainly rely on disks. Disks means persistent disks for Azure infrastructure as a service VMs, for example. The second service here is files, which is not available in Azure Stack today. Azure Files is kind of managed SMB, a managed file server PaaS service. And on the right side, you can see all the platform as a service services like custom apps, web and mobile, and so on. And these services mainly rely on things like objects, which is a highly scalable REST object store, tables, which is a NoSQL store, and queues, for example, for asynchronous communication between microservices or other componentized services. And at the bottom, you can see storage accounts. Everything relies on storage accounts, and the bottom box is Azure Stack infrastructure. Okay, from a tenant perspective, we have on one hand applications that are written, for example, in .NET, Node.js, Python, whatever you or your developers want to use. And these applications can communicate directly with blobs, tables, queues in Azure and in Azure Stack through our REST APIs and the client libraries that are available for more or less all common programming languages. And on the right side, you can see other ways to interact with storage. So for example, using PowerShell, CLI, Visual Studio, or even the Azure portal. And these things go through the Azure Resource Manager and use Azure Resource Manager APIs to, for example, create storage accounts, delete storage accounts, create images, and all these things. And at the bottom, you see the storage services, storage accounts with all the corresponding services. But everything is either, or the communication goes either through storage client libraries using the REST APIs or more operational things through PowerShell, the portal, which goes through ARM, and then in the end to the Azure Resource Manager REST API. When it comes to the admin or Azure Stack operator perspective, then we have a few more commands, a few more things to do, like recovering storage accounts, doing storage monitoring. So more things that are only relevant for an Azure Stack operator. And these things can be done, for example, through the Azure Stack PowerShell or through the admin portal. And these things use, again, the Azure Resource Manager and Azure Resource Manager REST APIs to manage all these services. So let's start with, and here's a quick comparison between disks in Azure and in Azure Stack. On the left side, you can see Azure. And the main difference here is that in Azure, our host communicates directly with the page blob REST API. And under the covers, we then have again a page blob, a binary large object, which means a VHD file. On the right side, we can see how it looks in Azure Stack. So again, we have our VM, we have our host, but the difference here is that we are not communicating with the page blob REST API, we're communicating via SMB. So the disk, the Hyper-V host, the VM is communicating with its disk using SMB. And then at the end, we again have a VHD file. What you can see here on the right is metadata. So when you want to create a disk, when you want to resize disks, all the operational things are done through Azure Resource Manager, through Azure Resource Manager APIs. And here are a few examples. So what you can see on the left side are typical operations that are triggered by the VM, like attaching a disk, like a page blob is leased by a VM, and of course read and write operations to the disk with all the things you have to consider like IOPS, latency, throughput. On the right side, you can see the REST API operations, the things I mentioned before as operational tasks, like uploading disks and images, taking snapshots, copying them, and so on. What's not possible are live snapshots and incremental snapshots today. Okay, so now as a tenant, how does it look like for me? First of all, I have, of course, my subscription, one or more subscriptions I can access through the tenant portal. And within my subscription, I can create a resource group. Within my resource group, I can create one or more storage accounts. And within my storage account, that's what you can see here, I have containers. And within these containers, I can store disks. And then I have my virtual machines that are accessing these disks. More or less same story for virtual machine scale sets. We again have multiple storage accounts, we have multiple VMs, and we can of course also have multiple subscriptions. That's on a high level the tenant. From an admin perspective, there are a few things to consider. So first of all, a bit about mapping and naming. So from the top, we can see we have multiple storage accounts, 1, 2, 3. Within our storage account, we have a container, container 1, and container 1 contains a page blob. And this can be translated to a volume, a directory, and a VHD file. So a page blob is in Azure Stack a VHD file, a container is a directory, and a directory resides on a volume. And in Azure Stack, we have one volume per node. So in a 4-node Azure Stack, you will see 4 volumes. Okay, and when we now store additional page blobs within the same container, this will end up on disk as multiple VHD files in the same directory on the same volume. When I now create a second container, this second container will show up or will get created on another volume, on the volume that has most free space available. And it doesn't really matter in which storage account we create containers. So what you can see here, now we have a storage account. We have a container with page blobs in storage account number 2, and a new directory gets created on volume number 2. Okay. So a few important things to note. First of all, containers. So the user can decide in which containers blobs are placed. And then, under the covers, the storage service selects the volume with the most available space for new containers. This is a mechanism that can be used to distribute the storage load or the utilization of your storage as best as possible. And then disks. So VMs can have more than one disk. They can have one or more. And the OS disk as well as the data disks are stored as page blobs. A good practice when you use unmanaged disks, and I'll explain the difference between managed and unmanaged in a second. When you have an unmanaged disk, a good practice is to place each disk into a separate container. And here's the reason why. So let's assume we have a whole bunch of virtual machines. You can see them here. So for example, 1, 2, 3. And these VMs have one or more disks, all of them stored in the same container. And what you can see here is that we are now limited to a single disk. So what happens when I create a virtual machine on Azure Stack? So starting on the top right, we create a new VM, for example, from a catalog image called K into a new blob B1. So we are the tenant here. We use the Azure Stack portal. The Azure Stack portal is a client for the Azure Resource Manager. So it doesn't matter if we use a portal or PowerShell, everything goes through the Azure Resource Manager. And the Azure Resource Manager now translates it into commands for the compute resource provider, the CRP, and the CRP interacts with the storage resource provider. So next step is now that the compute resource provider asks the storage resource provider for access path of B1. So next step is now that the storage resource provider puts a new blob B1 on its Azure consistent blob storage. After that, the compute resource provider asks the storage resource provider to copy from K to path B1. That's what you can see here. So our catalog image is now copied from our PRI file share into our new blob. And then the compute resource provider configures the Hyper-V host that's used under the covers for VHD access at path B1. And then the Hyper-V host is able to access the VHD over SMB. And last but not least, the tenant VM gets created. So as promised, managed disks. And for those of you who are familiar with Azure, this should be a known concept. So why should I use managed disks? First of all, we have a way easier manageability. So what we saw before, taking care of distributing your disks onto different disks and containers is something that's possible, but that is something that also has to be done. With managed disks, this is completely covered. So you don't have to take care of distributing your disks into multiple containers. Managed disks are a high-level concept, so you don't have to put them into a specific container in a specific storage account. That's done for you. Another benefit is that we now have disk level RBAC. We can use logs and we can also use tags on a per disk level. It also allows us to take snapshots, and it does automatic placement of disks in shares. So here's an example. This is what it looks like here at the bottom. This is one resource in our resource group, an Ubuntu VM managed disk. What's the current state? So managed disks are available for about a year now. Managed disks are supported since 1808. Right now there's no migration path, so you cannot migrate unmanaged disks into managed disks. They have a maximum size today of 1 terabyte compared to 4 terabyte that are available in Azure. Managed disk encryption is only possible using BitLocker, and the IOPS of a premium disk are based on the VM size. And last but not least, taking snapshots of disks attached to a running VM is not yet supported. You'll find a few more details when you follow this link to Azure Stack Managed Disks, differences and considerations. So how does it look like on the portal? What you can see here is how it looks to create a new virtual machine. And what you can see here is in step number 3 that we can configure storage to use or not use managed disks. And here are the details of a managed disk. What you can see here is that we have multiple creation sources. We have disk level RBAC, tags and logs, as already mentioned. We have snapshots, and we can do an export based on the SAS URI. Here are a few more details around snapshots. So what you can see here is the snapshot. We can export the snapshot, but we can also move it. And here's the direct comparison between managed and unmanaged disks. What you can see on the left is a virtual machine using a managed disk, and you can see here in the red box our managed disk as a top-level ARM object. On the right side we see the same VM with unmanaged disks, and you can see here we have our storage accounts, and within the second storage account we store our VHDs. So they're not a top-level ARM object. Next storage service, blobs, binary large object. So first of all, what is a blob storage service? So it's an object storage that allows you to store and serve unstructured data. What does unstructured data mean? So we have web and application data. We have, for example, big data from IoT. We have backups and archives. All of these things are considered as unstructured data, in most cases binary data. But other things are also possible. For example, human readable data like log files and text files and all these things. Key features of our blob storage is that it's scalable, it's durable. Today we have LRS, which is local redundant storage, because we have only a single scale unit today. The storage itself is highly available. It's strongly consistent. It's using storage spaces direct under the covers, and it allows you dynamically scale up on bandwidth. And it's also cost effective. So how does the process of uploading something look like? On the left side you can see our image JPEG, which is smaller than 256 megabyte. And you can see our Azure storage. And now you can see the REST calls. So put blob, it's a single REST call that can handle up to 256 megabytes. And each new put blob will replace the existing blob. Here's another example, a movie file with a size of 1 gigabyte. And what you can see on the right is the process of uploading large blobs. So in this case, we upload it chunk by chunk in smaller pieces to in the end have the whole 1 gigabyte transferred. This process allows us up to 100 megabyte per block, up to 50,000 blocks. And some of the benefits are efficient continuation and retry, and it allows us to upload chunks in parallel. So modifying blocks, updating something. Again, this is a process, committed, uncommitted blobs. You can see the REST calls on the right side. And in the end, we put it together using put block list. And upload only the changed parts. Okay, what you can see here is a screenshot of Azure Storage Explorer. So you can interact with your blob storage using the Azure Storage Explorer, upload, download files, and so on. And here's a screenshot from the Azure Stack portal where we can see a lot of metrics around storage accounts. And this is available through the administrator portal as well as through the tenant portal. So when a tenant creates his own storage account, he can see all this and all these metrics. Okay, how does the container distribution work? So this is another thing that you as an Azure Stack operator have to consider. So what you can see here should look familiar. We already saw it in the beginning. We see our storage accounts at the top. We see our storage services, and under the covers we have volumes. So let's now assume that one container reaches a size and reaches the maximum capacity of the underlying volume. This is what you can see here. So we have a single container that contains a large amount of large page blobs. That's something you should definitely avoid. So let's assume volume 1 is full. What we can do now is that we want to get rid of some data. And that means we want to transfer, for example, volume number or container number 3. So we create a new container on volume number 1, and then step by step we migrate all the page blobs into our new container on volume number 1. And what you can see here, this one is now empty and it gets removed. We have storage available on volume number 2. Few more details. So putting overflow and migration together, what you can see here is increasing used storage. So container overflow kicks in, and then you can start as an admin operation a volume rebalance. So container migration is done, and you can see we've now more available capacity on this volume. And then the consumption is again increased. Tables is a basic NoSQL implementation that's already available out of the box as part of an Azure storage account. Azure Tables is a NoSQL, it's a key value store. It has a flexible schema. It enables rapid deployment. So, for example, your developers can start using Azure Tables before they spin up their own infrastructure, which usually comes with more overhead. And here are some basic usage examples. So for example, you can develop an easy shopping cart, address book, device information, server status, events and metrics, and all these things. It's a good service you can start with before having the need of running your own NoSQL database. And again, the Azure Storage Explorer also allows you to interact with Azure Tables, and you can modify your tables using Azure Storage in a comfortable way. Again, how does it look like under the covers? We have our storage accounts, and within our storage accounts we have different tenant tables, and these tables are distributed across different databases on different volumes. A few limits and constraints. As of today, petition key and row key in the Azure Consistent Storage Table implementation are limited to 400 characters, and all petitions of a tenant table are stored in the same database. That's what we saw on the previous slide. And again, metrics. As a tenant, as an operator, you can see the metrics for your storage accounts. Queues. I mentioned it in the beginning of this presentation. Queues are a fantastic way to implement asynchronous communication between different components, between different parts of an application, or between microservices, for example. They're a simple and cost-effective way for queuing messages. You can access them using HTTP and HTTPS. Every message can be up to 64 kilobytes in size, and a queue can contain millions of messages. The usage examples here are more or less what I already mentioned. It allows you to implement asynchronous messaging between components. And again, The Azure Storage Explorer also allows us to work with our queues. Storage service. This is an operator task. So what you can see here is, in the first place, the usage of our tenant storage capacity. And that's another thing that we can retrieve using the Azure Storage Explorer. This is a typical capacity allocation we see in most scenarios today. So we have a tenant subscription. Within the tenant subscription, we have infrastructure as a service containing VMs, disks, images, snapshots, and so on. And we have a small part of diagnostic data, and we have app scenarios. In most cases, Blob Storage or tables and queues. Here you can see API versions. So this is something we already mentioned in different sessions, that all our Azure resources, all the things that can be addressed using Azure Resource Manager, have an API version. And in Azure Stack, these API versions are not necessarily the same, or not all API versions that are available in Azure are also available in Azure Stack. So as a developer who develops solutions for Azure or Azure Stack, this is something you should take care of to make sure that your API versions are available in Azure and in Azure Stack. And this is also true for client libraries used to access storage in Azure and in Azure Stack. Container management, we already talked a bit about containers. Important things here are capacity view and alerts, service health alerts, and in the table at the bottom you can see a few examples, like for example an infrastructure role is unresponsive or a physical disk has failed. All these things are shown up directly in the Azure Stack Administrator portal, or they are available using monitoring like SCOM or NetGeos. Few more management considerations. So in the tenant space, we have to manage quotas. This is really important. In Azure, this is done by Microsoft staff. In Azure Stack, you as an Azure Stack operator have to define quotas. You have to make sure that your tenants cannot consume all available storage, all available CPUs, memory in your Azure Stack. And for the administrators, there are also several tasks like manage use capacity, do a forecast, make sure that you order additional capacity early enough. When you already ran out of storage, reclaim space, migrate containers, and in case someone accidentally deleted a storage account, you can recover a deleted storage account. I mentioned reclaim capacity. So the storage account, or there's a retention time that you can configure in Azure Stack. And when a storage account gets deleted by a tenant and it's still within the retention time, you can still recover the storage account. But in case you're running out of storage, you can reclaim storage by deleting storage accounts that were already deleted but that are still in their retention time. And the other thing, and we saw it in the container overflow scenario, is migrate a container between volumes in case a volume is running out of space. Here's the retention time I mentioned before. So as an Azure Stack administrator, in the Azure Stack Administrator portal, you can configure a retention period in days. And this is the time that Azure Stack will wait before it physically deletes a storage account that was deleted by a user. In this case, 0 means that it gets deleted immediately. You can define it per region. It's defined in days, and the default retention period is set to 15 days. Okay, what we'll see now is an example of a deleted blob. So we are logged in as tenant admin 1 in the Azure Stack tenant portal. Subscription is my subscription. We are here using the template deployment. And we're copying a template from our Azure Quick Start template repository. What you can see here is a very simple example of how to deploy a storage account using an ARM template. A few parameters, in this case only the name for our new storage account. We're specifying an existing resource group. And we're clicking on create. So we'll take a few seconds and our deployment has succeeded. Here's our storage account. We can see our access keys, key 1 and key 2, for our storage account myarc2. Here's the key. Now let's have a quick look on containers. We have no containers in our storage account yet. We'll create a new container. You can specify the access type for your container. Here's our new container, CO1. And we can now use our script to upload something to our storage account using AZ copy, which is of course also available in Azure. And now you can see the difference. We now have all our files uploaded to our Azure Stack storage account. What we'll do now is selecting our storage account again, and now we'll delete our storage account, including all the data that is stored inside of our storage account. It asks us for the name of the storage account to make sure that we are not accidentally deleting the wrong storage account. And now our storage account is gone. What you can see here is that we now have no resources left in our subscription. What we'll do now is that we use the Azure Stack Service Admin to log on to the Azure Stack Administrator portal. And within the Azure Stack Administrator portal, we can see all our storage accounts, even the ones that are still in their retention period. You can see here the different status, active and our deleted storage account. There we go. My ACC2 status is deleted. We cannot access the data inside the storage account, but what we can do is we can recover this storage account as an Azure Stack operator. Clicking on yes will start the process of creating or recovering the storage account, and it will be available in the tenant subscription in a few seconds. Okay. So one of the last topics here is development kit guidance. You can test and develop all these things in the Azure Stack Development Kit, which is a shrink down version of a multi-node system that you can install on a single machine. But the Azure Stack Development Kit is not for production workloads. The Azure Stack Development Kit is also not optimized for performance and scale, and it contains only a single node. And that's it for storage for today. Thank you very much.